Okay, we are looking at section 8.3, which is about polynomial division. And the remainder theorem. So let's recall that a polynomial such as f of x equals x to the third plus 2x squared minus 5x minus 6 may be factored. All right? And the factored form of it, all right, would be x plus 3, x plus 1, x minus 2. And the zeros, all right, would be negative 3, negative 1, and 2. All right, so a polynomial can be factored. And then once it's factored, we can find the zeros. All right, so we're going to start off by talking about how division and factoring go hand in hand with each other. So what we're going to do here, right, we want to think about when we divide a polynomial, right, by another polynomial. We get two things. We get a quotient, which is just a fancy way of saying the answer. And we also get a remainder. Something that's important to note is that if the remainder is 0, then the divisor, what we divide it by, is a factor. All right, so that's going to be really important here, okay? If our remainder is 0, then the divisor is a factor. And let's not forget that our factored form, right, just consisted of factors, right? Factors, right, are these to that problem. All right, so what we're going to do is we're going to divide here. We're going to look at this specific problem that we're working with, and we're going to see, all right, we're going to take a look at this problem. And you're going to notice how we divide one of these. Maybe we have this polynomial, x to the third plus 2x squared minus 5x minus 6. If we divide it by x plus 3, we should get a remainder of 0. If we divide the polynomial by x plus 1, we should get a remainder of 0. And if we divide the polynomial by x minus 2, we should get a remainder of 0. All right, because once again, if the remainder is 0, then it is a factor. So let's take a look at this example. Let's divide it by, let's go with x plus 1. Right, so is x plus 1 a factor of this? Well, we have two methods of division, let's not forget. One of them is long division. The second is synthetic division. So we'll start it off with long division first. All right, so we do x to the third divided by x gives us x squared. That comes up here, and then if you recall, x squared, we're going to multiply it by x plus 1. And when we do that, we get x to the third plus x squared, right? And then we're going to subtract. We subtract, that's gone. We're left with 2 minus 1. That gives us 1x squared. We bring down our minus 5x. And once again, we divide 1x squared divided by x, giving us a positive x. That comes up here. X multiplied by x plus 1. And once we distribute, we get x squared plus 1x. We subtract, and we see x squared minus x squared is gone. And we see that negative 5 minus 1 is a negative 6x. We bring down our minus 6. And then we divide again. Negative 6x divided by x gives us a negative 6. Goes up there, and the negative 6 multiplied by x plus 1. Looks like gives us negative 6x minus 6. And looks like all that should cancel. Notice remainder is 0. All right, remember this up here we call the quotient. That is the answer. So back to the question. The question asked, is that x plus 1 a factor? Right? It sure is. Remainder is 0. So we can say yes. Since remainder is 0. Right, so this could have been done by long division, or it could have also been done by synthetic. So let's take a look at synthetic division. Right, so since it was x plus 1, right, we do the opposite. So we show minus 1. Remember, it's always the opposite. And we have to include the x to the third, the x to the second, the x, and then just our number. Back to our problem. All right, once again, we're looking at the coefficients. So x to the third, x to the second, x, and then our number. All right, so we're looking at that. So we have 1, we have 2, we have negative 5, and we have negative 6. Bring that down, and then remember we multiply those. Negative 1, remember in the inside we add. That's 1. Once again, we multiply out here. It's always multiply there. All right, that's negative 1. We add, that's negative 6. We multiply. That's 6. Remember out here, this is our remainder. Looks like we get 0 when we add those. Then since the problem started with x to the third, we subtract 1, and these are just our new coefficients. So it's 1x. Well, that's squared, so x squared plus 1x minus 6. All right, once again, we call that our quotient. And notice how that was the same as right up there. Right, so two ways of approaching this problem, right? If you're asked if it's a factor, you could do synthetic division or long division. And these problems should be nice review problems. They may not all look this nice. Let's take a look at another example here. How about and also one thing to note is that when we're talking about, we're talking about factors, but we can also talk about them being zero. So I can ask you if they're factors, or I can ask you if they are zeros of that polynomial, because they really go hand in hand with each other, right? So just keep that in mind. The question could be asked, hey, is it a factor or is it a zero? So let's take a look at an example where maybe I asked the question just a little differently. How about we say 2i 0 to g of x equals x to the third minus 3x squared plus 4x minus 12. So we use 2i, right, just like we did with our synthetic division, right? And we could put that out here, and we just work with the numbers. X to the third is 1, x squared is negative 3, x is 4, number here is negative 12. So the question is 2i a zero? Well, it all depends on this. Depends on the remainder. All right, we bring that one down. We multiply. Gives us 2i. Remember, we add there, but we cannot add because they're unlike. So all we can do is do negative 3 plus 2i. Then we multiply again. Do a little side work. We have 2i times negative 3 plus 2i. Right, let's not forget our i's. Properties that we learned. So it's negative what? 6i plus 4i, or in other words, negative 4i squared, right? Other negative 6i minus 4. Right, because remember, I squared turns into a negative 1. So that goes up here. Negative 6i minus 4. When we're adding those, notice that those will cancel, leaving us with negative 6i. And now we have to multiply 2i times negative 6i. Looks like that's negative 12i squared, or in other words, just a positive 12. And look at that, they cancel, so you get 0. So is 2i a 0 to this? Yes, it is. Once again, since the remainder is 0. All right. So this is a great problem. I put a little star on this one, know how to do this. I like this problem to put on the exam because it's a yes or no question, and I expect to see work on that. All right, so make sure you know how to work this really well. You'll see definitely a couple of I problems on your homework, so make sure you're comfortable with them. What else can we do here? And I think that's really what you're doing with all your homework. It looks like just a lot of synthetic division. Let's take a look at another example here. Is 2 minus square root of 3 or I take it back. So another thing that I do want to mention before we talk about this next example is that these remainders actually tell us the y value of a function. Or in other words, it evaluates it for you. Right, I think it's really important to understand. Right, let's go back to our first example. Right? So recall in first example, we go back to it. Right, we go back to our first example. What we see in this first example is we're working with this polynomial, right? And we know that all of these are factors, right? Therefore, all of them should give us or will give us remainders of zeros. So can we do this a different way? Right? Can we apply these a different way? Can we just evaluate them? All right, I think that is a possibility as well. All right, I think that we can evaluate them to get answers. So let's take a look. Let's try one of them out, okay? All right, so let's say, see what example I want to use here. So we have our problem, f of x was x to the third plus 2x squared minus 5x minus 6. All right, recall that we know that our factors are x plus 3, x plus 1, x minus 2, and we know that the zeros are negative 3, 1, and 2. Right, so I want you to find what f of negative 3 equals. In other words, find the y value. All right, so we evaluate it. Negative 3 to the power of 3 plus 2 times negative 3 to the power of 2 times negative 3 minus 6. What does that give us? You just put that in our calculator. You should notice that gives you 0. All right, so that's another way. We don't always have to do synthetic division or long division. I mean, we could always just evaluate it as well if we wanted to. All right, so I just want you to keep that in mind. This in reality is just the remainder. right? Right? If you were to do long division or synthetic division. So I just want to keep that in mind, okay? All right, one last example here. I want you to use synthetic division to find f of 2 minus the square root of 3. And your function is x to the 4th minus 16. So we're doing 2 minus square root of 3. And we have x to the 4th, after that x to the 3rd, then x to the 2nd, then x in our number. So it'd be 0 or 1 for the x to the 4th, then 0, 0, 0, negative 16. I remember that we did this stuff in the past. The polynomial has to go in descending order, and it's missing x to the 3rd, x to the 2nd, and x, so we just put zeros there. We bring this down, we multiply, 2 minus square root of 3. We add 2 minus square root of 3. Now we multiply. Looks like we got to do a little bit of work here. All right, looks like that's 4 minus 2 square root of 3 minus 2 square root of 3 minus square plus square root of 9. It's 4 minus 4 square root of 3 plus 3. That's 7 minus 4 square root of 3. That looks like. So then that goes up here. You add, that goes right here. Looks like we're multiplying again. And I'm showing every step. For those of y'all a little faster, you definitely don't have to show it all. That's 14 minus 8 square root of 3 minus 7 square root of 3 minus 4 square root of 9. 14 minus, what do we get there? 15 square root of 3 minus 4 times 3. Negative 15 square root of 3. This turns into 12, so 14 minus 12 gives us 2. So that goes right here. You add. Oh, I'm missing a little bit. Looks like I'm running out of space up there. Minus 2. Erase that. Okay, better. 15 square root of 3 minus 2. Bring my negative 16 out here more. Okay. Looks like we got to do it again. 2 minus square root of 3 times negative 15 square root of 3 minus 2. Looks like that's a negative 30 square root of 3 minus 4 plus 15 square root of 9 plus 2 square root of 3. All right, so then that looks like that is negative 30 plus 2, that's negative 28 square root of 3 minus 4 plus 15 times 3. All right. And what are we left with here? Oh, we're left with negative 28 square root of 3 minus 4 plus this 45, or negative 28 square root of 3 plus 41. We put that up here. And if we were to add that, all right, we get negative 28 square root of 3 plus, what do we get? We subtract there, we get 25. So let's take a look. All right, we brought that down, we multiplied. We get 2 minus square root of 3, we add. So now we multiply these. That's 4. Okay. We get this, bring that up here, we add, and it comes down. Once again, we're multiplying. That's 4. That's 8. That's 7. All right, that's good. We combine these, that's good. We bring that. This is 3. All right, we multiply, that's 12. Oh, take a look here, y'all. These two negatives make that a positive. Should be a plus. That should be a, I'm going to use a different color. All right, so that should be a plus. This should be a plus. So now we're adding 14 plus 12, so that's a positive. So to get positive what? 26, which means up here, it's a positive 26. Positive 26. So let's go back here and take a look. I have negative 30 square root of 3 plus 52 plus all right, we have negative 30 square root of 3 plus 52 plus 15 square root of 3, or square root of 9, minus 26 square root of 3. All right, so that's negative 56 square root of 3 plus 52 plus 15 times 3. Negative 56 square root of 3 plus 52 plus 45. In other words, negative 56 square root of 3 plus, what do we get? We add 52 plus our 45. We get our 97. So now we put that up here. And now from that 97, we subtract 16. So we get our 81 minus 56 square root of 3. All right, so a good problem here, just practicing multiplying some radicals. So you definitely see that on your homework as well. So I wanted to go over that. And if there's any other problems you want me to go over, just email me and I'll work them out. Thank you.